In this episode of Finno-Greek machining, in this very exciting episode of Finno-Greek machining, we are dealing with some linear shafting. And this piece of material is 25 millimeters thick linear shafting. It's from a device called Gerber. Oh yeah. And I will make the spindle shaft of this material. And now this is case hardened. It's hard outside, soft inside. So I need to cut a suitable piece out of it and then do some hard turning here. The other end will have a Morse 2 taper here inside. Then there will be a hole all the way through, and then the other end will have a bearing. It's not a tight fit, it's not a slip fit, but a good bearing fit. And then some threads, etc., so you can preload the bearings. So let's go on with this one. So the first thing, of course, is to determine how long a piece of this material we should cut, because it's very hard to handle, and after it has been cut, I will do that with an angle grinder, because you cannot hacksaw this. It's really, you will spoil your tools with that one. So I will. This is now the spindle. There is a bearing here. This thrust bearing, there is a needle bearing inside. And now the other surface is like that. There is that bearing. And now the shaft should end at this level. So I can now just put a stick inside there, like that, and then mark that for our length. This is not too critical, and yeah, so at least that much. Now there is some 5 millimeters too much, but it's okay. So now I know that I need at least this much, but then we need also at this end, we need some threads here, and then we need something to attach a handle or a drill attachment. So I have to figure out how much of that. You can shorten it from this end, because it's already turned smaller diameter. So if I now take this much and then add the threading for the bearing, and then a little bit more for like that. This is I believe about 5 centimeters. Let's see. 49 millimeters actually. My calibrated eye said that it's 5. So let's just put it about this long. That should be more than enough for our. So the bearing for the bearing is seated here, but then we need the thread for the bearing things, and then something to attach our things. So that should be enough. I shouldn't make it too long, because we need to drill the hole, and this is the drill I'm going to use, and it's actually on the limit. This has some features already in it. I need to cut first off that end. I don't want that to be there. And then take the piece of material and cut it again. 2 cuts with angle grinder. deviation will be to put this compound into a Morse 2 angle. And I didn't find any way to put it this way, because this is the way I would like to have it, but well, we can put it this way. So first of all, I have drill with a center drill. I made a center in a random piece of material, and I supported the center drill a little bit, so this should be quite in the center, but we will find out pretty soon whether it is or not, or whether this piece of Chinesium is well centered. Well, we shall see about that. And I assume that my tailstock is in the center at the moment. So when we are putting this here, like this, I would like to have some room here. That's too much room. Maybe there, like that. I will shoot down this. So there is our center now. So I lock this and lock also this. So we shall see how round this is. It's very easy to measure this one. Oh yeah, okay. But since this is the taper is this way, we need to measure the taper from the back side, so we get this angle like that. If I would measure it this side, I would need to drill the hole from the back side of the thing, and I don't have a suitable. Well, I do have actually a boring bar which could do the back side as well, but well, for me it is more convenient to be able to come to my side, and it's just more convenient. So let's see, first of all, let's see how round this is, how center it is. So let's rotate it. Well, it's quite accurate. 1/100 of a millimeter deviation there, and here. Oh, this is. And same here. Okay, it's accurate enough for us because that's the accuracy I'm aiming at, 1/100 of a millimeter. I'm looking for the maximum in the indicator. I know that it's in the center when it's in the maximum. Still rising. There you are. Yeah, got it. And now I will lock the carriage. I don't want it to move around. Now what I am aiming is zero deviation in that. Well, it's quite near already. It's here it is going 5 over, and here of course 5 under. Yeah, okay. So now because it is, this is so it's too far away on this side, so we should angle this way a little bit. And now let's see if this has any impact. I put it in the center. No, in this. So well, it certainly has. This has an. We need to knock this end a little bit. Really? Yeah. There you are. Now when I tighten this, I hope it doesn't move on me like it did when I didn't fix this. It didn't move at all. Good. And this one. Did not move at all. Okay. We have successfully, this is now Morse 2 taper angle. Well, this here is a CBN insert, and well, this is the first time I ever tried it. I don't know nothing about the speeds or feeds for this one, so your guess is as good as mine. So let's see. I try first like this, just try it out how it feels and set and so on. I tried already normal carbide in there, and it was really bad. It broke it right away. So let's see what this does. Feeding by hand at first. Well, it definitely does better job than the carbide. A lot better. Let's see. Oh yeah, okay. So now let's take 1/10 of a millimeter. This is quite a lot, and I believe we need a little bit more speed as well. Let's see about this. It didn't break. Well, and you probably can see that this definitely is case hardened. You can see the shiny portion there, that's the hardened part, and then starts the soft inside. So another 1/10 of a millimeter. Wow, I would say it's clean. Yeah, doesn't warm the piece up, but we got some blue chips out from there. Okay, so this is the insert I'm going to use when I for example, now I will chamfer this corner. It needs to be chamfered, so I will do this manually now. Okay, it's not perfect chamfer, but it's not sharp either, so you don't hurt yourself. Starting a hole straight. So, first of all, I'm using 8.5 millimeter normal drill here. This is just a starter hole for this one. This is also 8.5 millimeters, but it's a little bit longer. So, I have set the flutes of this drill in horizontal position, and I have here this thing I'm going to support the drill, just the tiniest amount here. I'm not pushing it, I'm just holding it there, in case it starts to wobble. It shouldn't, but if it starts, I can correct the situation with this one. So first I don't need it, but let's see if I need it. You can see if this starts to wobble around. And of course, yeah, there is a starter point there. And well, the speed is at the moment about 1000 RPM. Let's see how this goes. You can tell it's straight because the chips are almost equal from each groove, and it doesn't wobble. Good. This was not needed. Then I'll just keep on drilling. This is just to guide the long drill so it doesn't wobble when I start it down there. Well, this is a 14 millimeter drill, and again we are trying to, this is actually the width, a little bit more than the width of the tongue of Morse 2 taper, Morse 2 taper. So, and the length will be about end of the fuse. Well, we have this is the flimsiest setup so far. So there is a huge stick out and a very thin part. But yeah, I'm feeding with compound. I have to. The carriage is locked actually, and I'm taking 2/10 of a millimeter at a time. So let's go. Next 2/10. Yeah, it's a little bit musical. You can hear that the hole in there is not concentric. Take something out from there. Let's see if I turn it manually like this. that should be okay now. So what we need to do here is to peel off 5 millimeters from the diameter up to here. So okay, let's see. Okay, so far so good. No chatter. You know if my stop works. If not, I'm ready to do it manually. It works. Okay. Well, this is something. Ooh. So next cut. So that was 3, and we are really near there. So I need to do it like this. Now we go. Oh! What was that? That's CBN in action. This is now the make or break situation. So I will warm this up until it gets a little bit blue. Then it should be warm enough for me to drop in the shaft into there. We shall see. I'm using this butane torch for this thing. I already have here my backup plan. Hopefully that is not needed. Well, everything is clinically clean at the moment. It's dark blue outside, but it should be also dark blue inside. It is. Well, now, wish me luck. This is the part that should go in there. Wow, this is so exciting. Did it go? No, it did not. Okay. So 5 millimeters, probably 7. But this is not a total loss. It's just that I need to take away material. So that's always possible. Well, this side is a little bit difficult. I need to use the CBN to get the 5, maybe 7 millimeters away from this surface, and then back up. Well, let's see. But anyway, but with small diameters like this, the shrink fit is not very easy to do. Well, the whole diameter was actually quite correct because it went so far, but then it really decided not to go any farther. And to get it out from here, no way. It will stay there. And so what we will be doing in the next episode of Finogric Machining, we are going to fix this. And we are going to, well, make something at this end as well. But that will be in the next episode of Finogric Machining. Till then, see you!